Good morning, everybody. It is Thursday, and we are almost to vacation. Yahoo! Hopefully, we can do some fun things, even though it's COVID. So, after this, 2 weeks left. That's it. So, if your grades need improving, you really need to focus on this. So, today is 12/17/2020. We're going to talk about these special right triangles. So, there's two right triangles that we consider special because they have special properties. One is a 45, 45, 90 degree triangle. So I'm going to draw it. So here's what I know about a 45, 45. It's really got to be half a square. If you take a square and you cut it right down the diagonal, you wind up with half a square. So let me draw this. So these sides are equal, okay, because it really is half a square. And when I draw it in, I get this triangle right here, okay? 90 degrees, okay? So if this is 45, 45, and 90 degrees, it's really half a square. So if it's half a square, then these two sides are equal, okay? Now, if you want to find the hypotenuse, you could go through and do Pythagoras theorem. You could. But a faster or an easier way to do it is just to know the hypotenuse length. The length hypotenuse is always whatever this number is times the square root of 2. So it's like x squared root of 2. Okay, make sure you have that triangle somewhere in your notebook. Okay, so as an example, if I take a look at example 1, here is a 45 and of course 45, 90 triangle. Okay. Makes it half a square. It does. It makes it half a square. So if I know that this side is 8, half a square, then x has to also be 8. This is 8. Okay, half a square. 8 and 8 because 45, 45, half a square. And then we could do Pythagoras theorem. 8 squared plus 8 squared equals c squared. But it's faster to say that the answer is just 8 times the square root of 2. Now, I like that answer better. It's a nicer number than if I'd done this. If I'd done my Pythagoras theorem, 8 squared plus 8 squared, and if I square root that answer, I get an answer about 11.31. So, or y is approximately 11.3137, blah, blah, blah. Ugly number. How about we just say 8 squared root of 2? Much nicer. And that would be the hypotenuse, okay? Now, in example 2, let's take a look at example 2, okay? Now, example 2, when I look at example 2, these two sides are equal. Those two sides are equal. It's half a square, right? So that means this angle has to be 45 degrees and this angle has to be 45 degrees. And what happens is we've got the diagonal. The diagonal is 18 squared root of 2, so it is a square root of 2, right? So it means the 18 is the x, right? Which means the two sides have to be 18 and 18. So I'm going to take a look at this. If that's 18 squared root of 2, then this side is half a square, right? Square. That side's got to be an 18, and that side's got to be an 18. Okay, so I didn't put x and y, but x and y. Okay, 18, 18, and that's the answer, is 18, and the other side is 18. Okay. Now, 3 is a little bit different because right here on the diagonal, it should be some square root of 3. Okay, well, here's what we know. Our model, our formula is x squared root of 2, so the 12 is sitting where the x squared root of 2 is. So let's set the 12 equal to some x squared root of 2, and then we can find out what x is, okay? So we need to find x, so 12 is equal to the x squared root of 2, so let's solve. So if I take my 12 is equal to x squared root of 2, and I want to solve for x, right? I'm going to divide by the square root of 2 and divide by the square root of 2. Now 2 goes into 12 6 times, and the answer is a 6 square root of 2. Okay, and we can rationalize. I can show you more in detail when we're in class. But 6 square root of 2 is equal to x. Now, that's different because normally this would be a number, but this isn't x. This is a 6 square root of 2, which is a number, but an irrational number. So x is, this side is a 6 square root of 2, half a square, right? So if this is 6 square root of 2, this must be equal. It's half a square, so this is also 6 square root of 2, okay? All right, pretty easy, okay? Hopefully. All right, let's turn the page and look at the next one. So the next one is there's another special right triangle, and it's called the 30, 60, 90. So the angles are 30, 60, and 90 degrees, right? So if I drew a 30, 60, 90 triangle out, let's see what I can do. I'm going to draw, let's see, I'm going to do it right here. Draw this side. I just want you to see this, okay? I'm going to grab a pen. So if I draw in, let's see, there's that, and I want to see if I have a protractor on here somewhere. Okay, I've got my grandfather's protractor. It's kind of a cool protractor. All right, look at that protractor. Isn't that cool? So if I want a 60-degree angle, right there. Draw this line up. Okay, at 90. And I think I got to go up a little higher to make this work. There we go. And there we go. Okay, not perfect, but close enough, right? So, here's what I know, and that's got to be 30, which I can check, and sure enough, there's 30 degrees right there. Oh, I'll do it this way so you can see the 30. There's 30. See the 30? Anyhow, here's my triangle. It's a right triangle. There's my 90, so I need a 30, 60, 90 triangle. All right, so what do I do with this? Well, it also has special properties. So, this is the shortest leg of the right triangle, okay? The side, this side is, we can call just x, okay? Whatever it may be. Whatever it may be. Maybe it's 5, maybe it's 10. This side's always twice as big, only in the 30, 69 triangle. Whatever this side is, it's always twice as big, 2x, okay? So if this is 5, this is 10. If this is 6, this is 12. If this, but only in this triangle. If this is 12, this is 6, okay? If this is 14, this is 7. But this side, the other leg, is whatever this is, whatever this value is, times the square root of 3, okay? All right, make sure you have this triangle in your notes. There it is. It's our other special right triangle. Okay, from here then, let's take a look at example 4. So I took this triangle, it's kind of laying on its side. So the 12 is the hypotenuse. The 12, the hypotenuse is twice as long as this. X, 2x, right? So that means if this is 12, this side here has to be half as big to make it twice as big. So this side is 6. So I'm going to make, oh, I'm looking for the right pen, pencil, here we go. So this side here has to be 6. And then this side is whatever the 6 is times the square root of 3. So this is my longer leg, it's just tripped over. This is a 6 square roots of 3, okay? And whatever the 6 square roots of 3 is, well, you could do that on your calculator. Go 6 times square root of 3, but it's an ugly number, 10.39, blah, 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 but I'd prefer 6 square root of 3, so a nicer number. So y is equal to 6 square root of 3, or approximately equal to a 10.3923. Yeah, I like that number better. I don't like ugly numbers. Okay, now, number 3. Okay, same thing. Here the 18 is right here. Okay. So the 18 is sitting where the hypotenuse is. It's twice as big as this side, so this side is a 9. And this side is whatever this is times the square root of 3. 9 times the square root of 3. And then we're going to leave that number because that number is much nicer than the ugly decimal. Okay, now, I didn't draw this very well, but if it is 10, 10, 10, it's an equilateral triangle. Here's what we know. 180 degrees in a triangle, right? You know that. Hopefully you learned that somewhere in middle school or wherever. So if that's the case, if I divide it by 3, then I've got a 60, 60, 60 degrees. 60, 60, 60 makes 180. I know if all 3 sides are equal, then it's an equilateral. Now, what I want to do is find the area. So how do I find the area of a triangle? Well, the area of a triangle is equal to its base times its height divided by 3, right? Oh, divided by 2. I'm ahead of myself. Duh. Or, an easy way to write this is 1/2 base times height. So, what we need to do is figure out what the height is. I'm going to draw the height in. Straight down, I'm going to draw the height in. And when I draw the height in, that's the height of my triangle, what I've created is a 30, 60, 90 triangle and another 30, 60, 90 triangle. So let me just look at half of this triangle. So let's look at this half right here. Here's my 30, 60, 90 triangle, okay? So if this side is 10 out of 36 triangle, then this shorter side is half of that, right? We know that's got to be half because if that's 10, makes that 5. And then the height, if I look at my formula, height is going to be whatever it is times the square root of 3. So I'm going to make this 5 square root of 3, whatever the decimal is. So now, to go ahead and figure out what the answer is, my area, if this triangle's base, which we know the base is 10, times the height, which we know is 5 square root of 3, and divided by 2. So it's either going to be 25 square root of 3 centimeters squared. That's a great answer. Or the decimal equivalent, 25 square roots of 3, which is about 43.3, or approximately equal to 40.3 centimeters squared. Okay, that's all I have. It's pretty easy. This is the last assignment for the year, because when we come back, it'll be 2021. Whew, hopefully much better year. 2021's got to be better than 2020. Okay, I will talk to you during Zoom.